Hello friends, if still you haven't subscribed my channel, then subscribe it now by just clicking on the red subscribe icon and also click on the bell icon to get the quick updates on the latest uploaded videos. Today I am going to discuss about the VLAN concepts, which is a part of the OSI layer 2 switching. I will discuss about the data and voice VLAN, how to configure it in the switch, how two different VLANs will communicate with each other, what is ROAS, what is SVI, what is VxLAN, and a lot more. So be stay online and watch my videos. Good luck. I will cover the STP in my next video. Okay, so let's move ahead and discuss first about the VLAN and its concepts. So the first question that comes into mind is, what is VLAN? VLAN stands for Virtual LAN or Virtual Local Area Network. A VLAN is a logical grouping of network users and resources connected to administratively defined ports on a layer 2 and layer 3 catalyst switch. VLAN is a switching concept which create network partition and traffic separation at layer 2 of the OSI model. VLANs can be configured on both the layer 2 and layer 3 catalyst switches. By default, switches breaks up the collision domain and routers, which is a layer 3 device, breaks up the broadcast domain. But when we create VLANs in the catalyst switches, it allows to break up the large or single broadcast domains into smaller or multiple broadcast domain in a pure switched internetwork. A VLAN is therefore defined as layer 3 segmentation performed at layer 2 by the catalyst switch. One single VLAN equals to one single broadcast domain, which again equals to an IP subnet or a single IP subnet. But in case if we have multiple VLAN, then it equals to multiple broadcast domain, and again it equals to multiple IP subnet. VLANs lives in their own broadcast domain and cannot communicate freely with other VLANs and its broadcast domain. And for such communication, inter-VLAN routing concept is required, which can be fulfilled either with ROS or SVI feature, which I will discuss in more detail in my upcoming slides. Now let's see what is native VLAN. By default, native VLAN is the VLAN 1 in the catalyst switch, which is also known as the management VLAN. In the layer 2 catalyst switch, we can put the IP address only on the default VLAN 1, and that can be used as the management address so as to access the catalyst switch remotely via SSH or Telnet. VLAN 1 is the default VLAN with which all the switch ports belong to it by default. Now let's see the procedures and steps to configure the management IP address on the layer 2 catalyst switch. So in this case, first we need to access the switch via console because it's a new switch with no IP address on the management interface. And after accessing the switch using console, go to the global configuration mode of the switch and execute the command. The command will be, so the first command will be interface and go to that VLAN 1. So for execute interface VLAN 1. And once under that mode, then provide the IP address of that VLAN. So the command will be the IP address and whatever the IP address you want to put. Two different VLANs cannot communicate without the use of layer 3 device. It can be either a router, which is a layer 3 device, or layer 3 catalyst switch. Means by default, no host in a specific VLAN can communicate with any other hosts that are the member of another VLAN, as inter-VLAN routing or communication can only be possible by the use of either router with ROAS feature or by using layer 3 catalyst switch with having SVI feature on it. ROAS stands for router on a stick and SVI stands for switch virtual interface. VLAN ID. So every VLAN has a VLAN ID associated with it to keep the layer 2 frames unique in the VLAN traffic. VLAN ID is 12 bits long, allowing around 4095 unique VLANs plus VLAN, which is the default or native VLAN. Hence, the total capacity of unique VLAN is 4096. As VLAN has a limitation of around 4000 VLANs or segmentants only, so there is a new concept of VxLAN has been launched, which is mostly used in the cloud networking. VxLAN stands for Virtual Extensible LAN, which is 24-bit long, gives around 16 million segments. I will discuss a bit more about the VxLAN on my upcoming slides. Now let's see some benefits of using VLANs. Actually, there are a lot of benefits of using VLANs in an enterprise or organization as described, right? The first one is increased performance. The performance of the switches internetwork can be achieved by reducing the size of the broadcast domain, via which network device run more efficiently. By default, a catalyst switch has single VLAN, which is VLAN 1 or say native VLAN, and hence Catalyst switch has a single large broadcast domain. But this large broadcast domain can be reduced in size by creating multiple VLANs, hence increasing the overall performance. The second one is improved manageability. The division of the switched network using VLAN into logical group of users, applications or servers allows an administrator to understand and manage the network better. The third one is physical topology independence. VLANs allows to group users regardless of their physical location in the campus network. If department within an enterprise grows or relocate to a new area of the network, an administrator can simply change the VLAN on their new ports without making any physical network changes, hence giving the physical topology independence feature. The fourth one is increased security. A VLAN correlates to a subnet, means a unique VLAN has a unique subnet. The VLAN and subnet creates and defines exactly the same broadcast domain. An administrator should not attempt to have a single subnet in used in multiple VLANs, nor multiple subnets in a single VLAN. VLANs and subnets must always be deployed one to one. To reach other subnets or VLANs, the traffic must pass through a router or layer 3 device or catalyst switches, layer 3 catalyst switches. Anytime the traffic is sent through a router, there is an opportunity to add filtering options such as access list and other security measures, which in turn increases the switch inter-network security. There are several ways by which using VLANs will simplify the network management, like network adds, moves, and changes are achieved by configuring a port into the appropriate VLAN. A group of users needing high security can be put into a separate VLAN so that no users outside of that particular VLAN can communicate with them. As a logical grouping of users by function, VLANs can be considered independent of their physical or geographic locations. VLANs can enhance network security. VLANs increase the number of broadcast domain while decreasing their size. Because of security risk and congestion associated with having data and voice devices on the same network, Cisco always recommends that the isolation of IP phones in VLANs dedicated to voice devices and PCs in data VLANs. Now, let's discuss about VLAN membership. There are two types of VLAN memberships. First is static VLAN membership and another is dynamic VLAN membership. Let's discuss some features of the static VLAN membership. In static VLAN membership, there is a static VLAN binding or assigning of switch ports to each VLAN. It is the usual way of creating VLAN and considered to be more secure than dynamic VLAN because the VLAN binding or association to the switch port is always be there in the switch until an administrator manually do the changes in the port assignment. Such type of VLAN configuration is comparatively easy to set up and monitor, and it works well in a network where the movement of users within the network is controlled. The second one is the dynamic VLAN membership. Dynamic VLAN is the binding of MAC address of the host devices with the particular VLAN with the help of VMPS. VMPS stands for VLAN Management Policy Server. A Cisco administrator can use the VMPS whose database maps MAC addresses to VLANs. A dynamic VLAN determines a node VLAN assignment automatically. Such type of VLAN membership is not so popular. In such VLAN membership, host devices MAC addresses has to be entered into a centralized VLAN management application. So in case if a node is attached to an unassigned switch port, the VLAN management database can look up the hardware address, then automatically assign and configure the switch port to the correct VLAN. This is a pretty cool feature as it makes management and configuration easier because if a user moves, the switch will assign them to the correct VLAN automatically. But it but a lot of more work needs to be done in the initial setup of the database. Okay, so now let's move ahead and discuss something about the concept of identifying the VLANs and its trunking and frame trackings. Layer 2 frames, when switches through the network, are handled differently according to the types of links they are traversing. The link here I am referring to is either the access link or the trunk link. There are two types of links in a switched environment. The first one is the access link and the second one is the trunk link, which an administrator can configure in the Catalyst switch port. Access link or port will carry the traffic of only one VLAN at a time for the one it is assigned for. Whereas trunk link or port will carry the traffic of multiple VLANs simultaneously for which it is defined for, or all VLANs present in that switch, which is up to a maximum of 1005 VLANs. This is also known as tagged port, as the VLAN information is tagged to the layer 2 frames while traversing the trunk link. Let's discuss some features of access links. Access link is referred to as the native VLAN of the port. Any device attached to an access link is unaware of the VLAN membership. The device just assumes it's a part of a broadcast domain, but it has nothing or no understanding of the physical network. Switches remove any VLAN information from the frame before it's sent to an access link device. Access link devices cannot communicate with devices outside their VLAN unless the packet is routed, which can be possible only by the use of inter-VLAN routing feature, which I will discuss later. Now let's see some features of trunk links. Trunk link or port can carry the traffic of multiple VLANs and originally gained their name after the telephony system trunks that can carry multiple telephone conversations. A trunk link is a 100 or 1000 Mbps point-to-point link between two switches, between a switch and a router, or between a switch and server. Trunk link can carry the traffic of multiple VLAN for a maximum capacity from 1 up to 1005 at a time. By default, all VLANs of a particle switch are configured on a trunk link unless specified by an administrator for particular VLANs. Trunk ports are often called as tagged ports because the switches send frames between each other with their VLAN tagged in place. Now there are some requirements for a switch port to be a trunk. Let's discuss it one by one. The first requirement is that the port speed must be same on both the ends, else the trunk link will not come up. The second requirement is the duplexing methodology. It should be full duplex on both the ends, not the half duplex. The third one is the trunking protocol, which can be either ISL or 802.1q or .1q simple, which must be same on both the ends. The basic purpose of ISL and .1q frame tracking methods or protocol is to provide inter-switch VLAN communication. The last is that the trunk feature must be enabled on that link or port. Next is switch fabric. Switch fabric is basically a terminology given to a group of switches sharing the same VLAN information. Now let's discuss a bit on the frame tagging relationship with the VLAN ID. VLAN ID is a unique identification of VLAN which is tagged to the layer 2 frame, known as frame tagging. As you can see in the diagram aside, okay, the catch here is that once the frame reaches to an exit of an access link matching the frame's VLAN ID, the switch removes the VLAN identifier. This is so the destination device can receive the frame without having to understand their VLAN identification. But the tagging remains intact if the frame goes out of the trunk link. The same you can see here. This is a frame which is passing through a trunk link and the VLAN tag is intact there when it's passing through the trunk link. Now let's discuss something about trunking protocols. There are two types of trunking protocols which are used for the VLAN identifications. VLAN identification is what switches use to keep the track of all those frames as they are traversing a switch fabric. It is how switches identify which frame belongs to which VLAN. If a member of X VLAN sends a broadcast message, it goes to all X VLAN ports on the connected switch. But the connecting switch port must be a trunk port. The first method of trunking is ISL. ISL stands for Inter-Switch Link. Let's go through some of its features. Cisco created this ISL protocol, and hence it is a proprietary to Cisco switches or devices only, and is used for fast Ethernet and gigabit Ethernet links only. ISL is an external tagging process. Hence, the original frame is not altered. It only encapsulates the frame header by adding header and trailer to the frame. ISL will apply 26 bytes of header and 4 bytes of trailer on original 802.3 header frame. The trailer can be FCS or CRC. FCS is frame check sequence. ISL is not a tagging protocol, but an encapsulation protocol. ISL don't understand the concept of native VLAN. ISL supports a maximum of 1024 VLANs. ISL function at layer 2 by encapsulating a data frame with a new header and CRC as trailer. CRC stands for cyclic redundancy check. Latency will increase with the use of ISL. Delay will also increase between the ISL frames and performance will goes down. Now the question is where we can use ISL routing. ISL routing can be used on a switch port, router interface, and server interface card to trunk a server. Using ISL can be a very good approach if an administrator is creating functional VLAN and don't want to break the 80-20 rule. What is 80-20 rule? It's a formula which says 80% or more of the data traffic should stay on the local segment while 20% or less crosses a segmented device. A trunked server is a part of all VLAN broadcast domain simultaneously, so user don't have to cross layer 3 device to access it. ISL VLAN information is added to a frame only. If the frame is forwarded out, a port configured as a trunk link. The ISL encapsulation is removed from the frame if the frame is forwarded out an access link. The second method for trunking is IEEE standard 802.1. It is also known as .1Q trunking protocol. It is an open standard protocol, means it is not a Cisco proprietary and is open to any vendor devices as it is IEEE standard. It understands the concept of native VLANs. It supports up to the maximum of 4096 VLANs. It applies 4 bytes tag after source MAC field in original 802.3 Ethernet frame. It is created by IEEE as a standard method of frame tagging. It actually inserts a field into the frame to identify the VLAN. If the trunking needs to be set up between a Cisco switch link and non-Cisco switch link or devices, then .1q must be used for the trunk to work. By default, native VLAN is the VLAN 1. ISL will apply 26 bytes of header and 4 bytes of trailer on the VLAN 1 traffic, while .1q will send the VLAN 1 traffic untagged. Because .1q understands the native VLAN concepts, but ISL does not. VLANs are not a Cisco-only technology. Just about all managed switches vendors support VLANs. For VLANs to operate in a mixed vendor environment, a common trunking or tagging protocol must exist between them. So the protocol in common usage is the IEEE standard 802.1q. All vendors design their switches to recognize and understand the 802.1q tag, which is what allows to trunk between switches in any environment. Let's see one example of VLAN tagging when a data is sent from host A to host D as shown in the diagram here. In this process, the PC will never know. Means the PC will never knows what VLAN it's belong to because it is at the access link level. Access link level. The VLAN tag is applied by the switch as the frame is processed by the incoming port and preserved as the frame passes from a trunk between switches. The VLAN tag is removed when exiting a port at a destination PC. VLANs are switching concepts. The PC never participate in the VLAN tagging process. The untagged frame is sent to host D. But some server class network cards support trunking, which allows to extend the VLAN tagging into the server so that it can perform different operations based on the source VLAN of the frame. DHCP is one example. Multiple source VLANs needs IP address assignment in different subnets. So using a trunk connection on a single network interface is one way to simplify DHCP server implementation. Okay, now let's move ahead and discuss something about VTP, VLAN Trunking Protocol. VTP is created by Cisco but not a proprietary of it. VTP is a misnomer as it's not a trunking protocol like ISL or .1q. VTP is a VLAN database management protocol used to maintain or manage all configured VLANs across a switch internetwork so as to maintain the consistency throughout the network. With the help of VTP, an administrator can create, delete, and modify or rename VLAN information from one place, which is then propagated to all other switches in the VTP domain. And that information gets updated with the help of revision number. VTP is a layer 2 messaging protocol. VTP domain can be used if there are more than one switch connected in the network. But if all switches are in single VLAN, then VTP is not required. Now let's discuss about the VTP operational modes. There are four operational modes within a VTP domain: server mode, client mode, transparent mode, and off mode. The first one is the server mode. It's a default mode of all Catalyst switches. Need at least one switch on server mode in the VTP domain to propagate VLAN information throughout the domain. In this mode, the administrator can create, modify, and delete VLANs in a VTP domain. In this mode of VTP, server configurations are saved in NVRAM and switch can send and forward advertisements. Means changing VTP information must be done in the server mode so that any changes made on a switch in a server mode will get advertised to the entire VTP domain. The VLAN configuration is synchronized in this mode. Next is the client mode. In this mode of switch, the administrator cannot create, cannot modify, and cannot delete VLANs, but can receive the VLAN database information sent by the server. In this mode V of VTP, client configurations are not saved in NVRAM. Means VLAN information sent from a VTP server is not stored in NVRAM, but it can send and forward advertisements. In client mode, switches receive information from VTP server and also can send, receive, and forward updates. Means none of the ports on a client switch can be added to a new VLAN before the VTP server notifies the client switch of the new VLAN. The VLAN configuration is synchronized in this mode as well. Next is the transparent mode. In this mode, switch works as a server, but as a standalone server or say locally significant, as it will not participate in the VTP domain. In this mode, switch will create its own VLAN database and can create, modify, and delete locally significant VLANs only. But it will neither send nor receive any VLAN update. In this mode, switch will forward the VTP information received through trunk ports, but does not accept information updated or update their VTP database, just forward the advertisements. In this mode of VTP, transparent configurations are saved in NVRAM. The purpose of this mode is to allow remote switch to receive the VLAN database from a VTP server configured switch through a switch that is not participating in VLAN assignment. The VLAN configuration are not synchronized in this mode as it's only local to its switch. Last one is the off mode. A switch in VTP off mode functions in the same manner as a VTP transparent mode switch, except that it does not forward VTP advertisements on trunks. The VLAN configured the VLAN configurations are not synchronized in this mode. Okay, so let's move ahead and discuss something more about VTP and its features. Let's discuss something about VTP advertisements. Then we will discuss about VTP versions. Then we will discuss about VTP implementation requirements. Let's first discuss about VTP advertisements. Each switch in the VTP domain sends periodic global configuration advertisements from each trunk port to a reserved multicast address. Neighboring switches receive these advertisements and update their VTP and VLAN configuration as necessary. Because trunk ports send and receive VTP advertisements, an administrator must ensure that at least one trunk port is configured on the switch and that this switch port is connected to the trunk port of another switch. Otherwise, the switch cannot receive any VTP advertisements. VTP advertisements distribute some global information like VTP domain name, VTP configuration revision number, update identity and update timestamp, MD5 digest VLAN configuration, including maximum transmission unit MTU size for each VLAN, frame format. VTP advertisements also distribute VLAN information for each configured VLAN, like VLAN ID, VLAN name, VLAN type, VLAN state. Additional VLAN configuration information is specific to the VLAN type. In VTP version 3, VTP advertisements also includes the primary server ID, an instance number, and a start index. Now let's discuss about the VTP versions. If an administrator uses VTP in an enterprise network, he must decide which version of VTP to use. By default, VTP operates in version 1, but currently there are three versions of default VTP. Default is the version 1, then version 2, and version 3. VTP version 3 has some enhanced authentication feature which were not in VTP version 1 and 2. Now let's see something about the requirements. The requirements to implement VTP. The first one is the trunk must be enabled. As VTP information is sent via a trunk port only, not via access port. Next is VTP domain must be same in all the switches. There is a point to note that a switch can only be a part of single VTP domain at a time. Next is at least one switch must be in a server mode where an administrator made the changes and it will get floated to another switches. Apart from this, the rest of other switches can be either in the client or transparent mode. Next one is optional, which is VTP password, which must be same. But there is a catch here that if it is applied and if applied on one switch, then it must needs to apply on all other switches, which can be difficult as it's a manual task. So it's optional. Below are the steps to configure VTP domain. Step 1, go to the global configuration mode of the switch using the command configure terminal. To configure the VTP domain, execute the command VTP domain and the domain name. Step 3, to configure the VTP mode, execute the command VTP mode and then type the whatever the mode you want, server, client, transparent. Now let's go through some benefits of VTP. There are a lot of benefits of configuring VTP in the enterprise switch environment. The first one is the consistent VLAN configuration across all switches in the network. The second one is VLAN trunking can be possible over the mixed networks such as Ethernet to ATM lane or even FTTI. The third one is the accurate tracking and monitoring of VLANs. The fourth is the dynamic reporting of added VLAN to all switches in the VTP domain. The fifth is the plug and play of VLAN adding. VTP configuration revision number. This is one of the most important concept in VTP, which, if not known to an administrator who is managing the switched network, can wipe out the switch configuration following the addition of new switch in the network, which may be in the server mode with a high revision number. Switches advertise VTP management domain information in the switch network in the VTP domain, the same domain, as well as the configuration revision number and all known VLAN with specific parameters. VTP updates are sent out as revision number that are the notification plus one. Anytime a switches see a higher revision number, it knows the information that it's receiving is more current and it will override the current database with the new information. Now let's see the most important concept of VTP following the revision number, which must be taken care while adding new switch in the switched network. If an administrator wants a new switch to become a server in the switched network, then first make it a client before adding to the network so that it receives all the correct VLAN information while putting into the network, then change it to a server. Use VTP only when there is more than one switch in the network and have multiple VLANs. If there is having an existing switch network and an administrator wants to add a new switch, then he must make sure to configure it as a VTP client before installing it in the switch network. Reason is, as it might be possible that this switch is in server mode, is with high revision number and has no configuration, and will send out a new VTP update to all other switches, effectively wiping out all the existing VLAN. Now let's discuss about VTP pruning. VTP provides a way to preserve bandwidth by configuring a VTP feature to reduce the amount of broadcasts, multicasts, and unicasts. This feature is called VTP pruning. Hence, VTP pruning increases network available bandwidth by restricting flooded traffic to those trunk links that the traffic must use to reach the destination devices. Without VTP pruning, a switch floods broadcast, multicast, and unknown unicast traffics across all trunk links within a VTP domain, even though receiving switches must discard them. VTP pruning is disabled by default on all switches. VTP pruning only sends broadcast to trunk links that truly must have the information. Like if switch A does not have any ports configured for VLAN 5 and the broadcast is sent through for VLAN 5, then that broadcast would not traverse the trunk link to switch A. Enabling VTP pruning on a VTP server enables pruning for the entire VTP management domain. Making VLANs pruning eligible or pruning ineligible affects pruning eligibility for those VLANs on that trunk only, not on all switches in the VTP domain. VTP pruning blocks unneeded flooded traffic to VLANs on trunk ports that are included in the pruning eligible list. Only VLANs included in the pruning eligible list can be pruned. By default, VLANs 2 through 1005 are pruning eligible switch trunk ports. But VLAN 1 can never be pruned because it's an administrative VLAN. VTP pruning is supported in all VTP versions, version 1, 2, and VTP version 3. Now let's discuss about inter-VLAN routing. Routing between VLANs. A layer 3 device is required for any host or any IP addressable device to communicate between different VLANs. We can use a router as shown in the diagram here. that has an interface for each VLAN or a router that supports ISL routing. The least expensive router that supports ISL routing is 2600 series router. 1600, 1700 and 2500 series router don't support ISL routing. But if there are more VLANs available than a router interface, then an administrator can run either ISL trunking on one F interface or buy a L3 switch such as Cisco 3550 or 3750. If a router interface are plugged into an access link, this means that each of the router interface IP address would then become a default gateway address for each host in each VLAN. But instead of using a router interface for each VLAN, an administrator can use a single interface as shown in the diagram and run ISL or 802.1q trunking protocol. This allows all VLANs to communicate through one interface. Cisco call this a ROS. ROS stands for router on a stick. Communication between different VLANs can be achieved either through ROS, which is a CCNA topic, or SVIs, which is a CCNP topic. Let's see the requirements for inter-VLAN routing. The first one is trunk must be enabled between the devices. The second is different VLAN belongs to different IP subnets. The third is required to create sub-interfaces on the router, Ethernet port or FE port. We need to create the sub-interfaces in the router. I will discuss more on ROS configuration on my upcoming slides. Now let's discuss something about data and voice VLAN. Voice VLANs are required when an administrator is attaching any IP phones to the switch so as to get it registered with the call manager server. Voice and data traffic must be separated by using VLANs. Additional security layer can be achieved or provided by separating voice and data traffic using VLANs by preventing data applications from reaching the voice traffic. It also gives a similar method to deploy QoS, prioritizing the voice traffic over the data using the VLAN as an identifier. SRTP is Secure Real-Time Protocol, which is used to encrypt the audio. Then we have multi-VLAN access port. Let's see what is multi-VLAN access port, MVAP. Traditionally, a switch port on a Cisco switch which receives tagged packet is referred to as trunk port. However, when an administrator configures a switch port to connect to Cisco IP phones, here he configured it as an access port for untagged data from PC, untagged data from PC, as you can see in the diagram. These ports, when configured like this, such that having both data and voice VLAN are called multi-VLAN access ports. And also you can see there is a tagged voice packet. Okay, means supporting tagged traffic from the IP phones. Tagged, okay, so tagged voice packets from the IP phones and untagged data packets from the PC. The access port with voice VLAN is called multi-access port. So it is access port but technically act as a trunk port that carry VLAN tags for voice VLAN and cost marking as well, but needs to be trusted on the switch port level. Now let's see something about CDP and LDP. Both works at the layer 2 of the OSI model. The voice VLAN is negotiated by the help of CDP, which is Cisco Discovery Protocol, and is a Cisco proprietary. But with other vendors, the marking methods might be different, and there is no CDP but LLDP. LLDP stands for Link Layer Discovery Protocol, which is an open standard protocol. Cisco IP phones receives the voice VLAN configuration in the formation from the switch via CDP. After it receives the voice VLAN number, the IP phone begins tagging its own packet. Non-Cisco IP phones cannot understand CDP packets, but the LLDP. This typically requires an administrator to manually configure each of the non-Cisco IP phones with its voice VLAN number from a local phone configuration window on the IP phone handset. Configuring voice and data VLAN to the Cisco Catalyst switch is fairly a simple process. Let's see the steps to configure both the data and voice VLAN in the switch. The first step is to log in to the layer 2 or layer 3 switch. Then go to the configuration mode of the switch by executing the command configure terminal. Then execute the command VLAN and give the VLAN ID to create the VLAN and the command name, then VLAN name to give the name to it. Use the same command to create both the data and voice VLAN. Then step 4, go to the exec mode of the switch and execute the command show VLAN brief to see the list of VLANs in the switch as well as access ports. Trunk port will not be visible in this command output. In step 5, assign the data and voice VLAN to the single switch port using the command in the global configuration mode in a single switch port interface. Below is the sample configuration for IP phones for voice VLAN and connected PCs or laptops. Go to the interface, any interface like interface F0/2. Execute the command switch port mode access. Then execute the command spanning tree port fast. Then assign the access VLAN, the data VLAN, using the command switch port access VLAN 10. Then assign the voice VLAN using the command switch port voice VLAN 10. Now, if you want to assign the voice and data VLAN to multiple or range of switch ports, Then use the interface range command like below. Interface range F0 slash 2 dash 10 means you are configuring the switch port from range 2 till 10 with those VLAN ID and execute the command switch port mode access spanning tree port fast spanning switch port access VLAN switch port voice VLAN etc. Now in step 6 you want to verify the list of VLANs and its port, then execute the command show VLAN brief in the exec mode of the switch. Now let's see what is spanning tree port fast. Spanning tree port fast must be enabled on the port where connecting the IP phones because the IP phones will boot quickly and request a DSCP assigned address before a typical port with spanning tree enabled will go active. It's a part of discussion in STP spanning tree protocol, which I will discuss in more detail in my next video. Okay, so now let's ahead and discuss something about the SVI and its basic. SVI is interface VLAN and it's a logical, not physical. It stands for Switch Virtual Interface. It is a logical interface associated with the particular VLAN or management interface. SVI is a virtual LAN of switch ports represented by one interface to a routing or bridging system. There is no physical interface for the VLAN and the SVI provides the layer 3 processing for packets from all switch ports associated with the VLAN. To configure the SVI, layer 3 catalyst switch is required. The steps to configure the SVI in layer 3 is very simple. Go to the global configuration mode of the layer 3 switch and execute the command interface VLAN and the number, whatever the VLAN you want, and then provide the IP address and the masking of it inside that. Similarly, you can create another interface VLAN, void, whatever, and provide the IP address and masking under that. Now let's see the difference, the basic difference between layer 2 and layer 3 switch. A layer 2 switch does switching only. This means that it uses MAC address to switch the packets from a source port to the destination port. It therefore maintains a MAC address table so that it can remember which port has which MAC address associated. Layer 3 switch also does switching exactly like a layer 2 switch, but the layer 2 switch has an identity from the layer 3 switch. Practically, this means that a layer 3 switch is capable of having IP address and doing the routing. For intra-VLAN communication, it uses the MAC address table. For inter or extra VLAN communication, it uses the IP routing table. Now let's see how to configure ROAS, which is a router on a features so as to achieve the inter-VLAN communication, which is frequently used in the IP phone environment. ROAS is the most important feature which is used in an IP phone configuration. Let's go to the steps so as to configure ROAS. In this configuration, we will see the steps and commands used to configure both the router and the switch. Let's first see the steps so as to configure the switch. Step 1. Create two VLANs, one for data and another for voice, using the command as below in the global configuration mode. Create a VLAN 101, 201 and assign a name as admin data and admin voice. Step 2. Assign both the VLAN, the data and voice VLAN, to a switch port using the command in the switch port like go to the interface, then fire the command switch port mode access, spanning the port fast, then assign the data and voice VLAN to that switch port with the command switch port access VLAN 101 and switch port voice VLAN 102. Now configure one interface as a trunk in the switch which is connected to the router for the ROS using the command go to that interface F02 which is connected with the router, execute the command switch port mode trunks to enable the trunking, then provide the speed 100, then provide the duplexing method duplex. Let's first see the steps to configure the router now. Step 1. Create a sub-interface in the router corresponding to the data VLAN and assign the trunking protocol to it using the below commands. Go to the interface F0/0, fire the no shut command. It might be in a shutdown states, admin shutdown states. Then create a sub-interface with the command interface F0/0.101. 101 here is the reference to the data VLAN. Then fire the encapsulation method, the trunking protocol, with the command encapsulation dot 1Q101, which is the reference to the data VLAN. Similarly, create another sub-interface corresponding to the voice VLAN. Assign the trunking protocol to it using the command create interface, sub-interface, interface F0/0.102, 102 which refers the voice VLAN and fire the command encapsulation.1Q102. So this is how ROS is configured and you can take a reference of the command from this diagram. Okay, now let's discuss something about the VxLAN, only basics. VxLAN stands for Virtual Extensible LAN and LAN is local area network. VxLAN is IEEE standard based on RFC 7348, means it's open standard and can be used by any vendors. IEEE stands for Institute of Electrical and Electronics Engineers. VxLAN is a concept which is frequently used in the cloud networking because of its very much high segmentation capacity as compared to normal VLANs. VxLAN is the hosted method. VxLAN is quite similar to VLAN. Like each VxLAN segment also has an identifier called a VNI. VNI stands for VxLAN Network Identifier. Just like VLAN, traffic in one VNI is kept separate from every other VNI, and hence a router is required to mix traffic from different sources. VxLAN ID, which is VNI, is a 24-bit long identifier, which gives around 16 million segments. VxLAN helps in achieving the true isolation of servers from multi-tenancy, which cannot be achieved by the normal VLAN, which has a max capacity of 4096. It works like a layer 2 bridge. It helps in simplifying the underlying network and reduce the need for the spanning tree, trunking, and stretching VLANs. VMs can move between hosts on different VLANs or without the need to fiddle with different IP address. VxLAN can cross layer 3 boundaries. VxLAN can be supported on hardware or software platform. An advantage of this is that it can run on a hypervisor like EXXI or a hypervisor 5. Thanks friends for watching my video. Have a nice day.